This is a slideshow about Juno, the spacecraft, by Luke Prescott.
Mission Brief. Juno is a spacecraft constructed by Lockheed Martin to orbit the planet Jupiter for research. Juno has also surveyed some of Jupiter's satellites. The probe was launched aboard an Atlas V rocket on the 5th of August of 2011 and reached Jupiter's orbit on the 4th of July of 2016. Mission Juno was initially planned to conclude in 2017, but its extended mission lasted from then until at least September of 2025. More on this in the next slide. NASA itself states that, quote, Juno's principal goal is to understand the origin and evolution of Jupiter. Underneath its dense cloud cover, Jupiter safeguards secrets to the fundamental processes and conditions that likely governed our solar system as it formed. Paraphrasing what follows, the motivation behind sending a spacecraft to Jupiter is that since it's suggested that the solar system formed out of the collapse of a, quote, cloud of gas and dust, and Jupiter is essentially made of gas and dust, it would make sense to try and get a closer look. Doing so could possibly provide insight into the formation of the solar system. The weeds. Mission Juno was initially planned to conclude in 2017, but its multiple mission extensions have continued it from then until at least the 30th of September of 2025. The mission is assumed to have concluded, but due to and since the recent government shutdown, no definitive official news has surfaced about the probe's status or any new future plans regarding it. It is assumed based on existing info that Juno will either continue its mission until contact is lost or crash into Jupiter as planned. The decision to guide Juno into Jupiter's atmosphere is to avoid contaminating any nearby moons, such as Europa, for which future research is planned and in part underway. The last article regarding Juno on NASA's website is from early September 2025 as of the creation of this presentation. Future perijoves or Jupiter flybys are planned. An animation of Juno's trajectory can be viewed here.
The second Donald Trump administration has proposed a budget cut of around 25% from NASA as a whole and around 47% from NASA's Science Mission Directorate for the fiscal year of 2026. These changes, if voted in by Congress, would force many of NASA's ongoing missions to shut down, including Juno. As of the creation of this presentation, Juno is still orbiting Jupiter and in contact with Earth.
Jupiter is a gas giant, the first outer planet, and the fifth planet from the Sun. It is the largest planet in our solar system. Juno is the second spacecraft to ever orbit Jupiter. There are 3 Lego minifigures aboard Juno, one of Galileo Galilei, another of the Roman god Jupiter, and the third of his sister and wife, the goddess Juno. One of Jupiter's moons, Ganymede, is the largest moon in the solar system. Over 1,000 Earths can occupy or fit inside Jupiter's mass. Organizations involved. Many people and agencies aside from the big 2 previously mentioned were in some way involved with Juno's construction. Sierra Nevada Corporation is to thank for Juno's thermal regulation systems, and BAE Systems provided it with its main computer. Mission Juno also has many key contributors from outside of the United States. The Italian Space Agency provided the orbiter with its GIRIM instrument. A company called Horiba Joven Ivan, that makes science instruments, provided spectroscopy components, and a British company, Moog ISP, built the spacecraft's main engine, Aleros 1B. Agencies and research institutions from France, Belgium, and Denmark have also made major technological contributions to Juno. People involved. While NASA's JPL, or Jet Propulsion Laboratories, handles the mission itself, the Southwest Research Institute houses Juno's scientific research team, with physicist Scott J. Bolton serving as its principal investigator. Juno's research is also done in collaboration with various independent researchers, agencies, and institutions, both domestically and abroad. Design. As stated earlier, Juno is a solar-powered probe built by Lockheed Martin in partnership with NASA's Jet Propulsion Laboratory to orbit Jupiter for research. Designing a spacecraft to survive the most dangerous radiation the solar system has to offer, the sun notwithstanding, as well as a magnetic field 20,000 times stronger than Earth's, isn't easy. Jupiter emits
emits many types of radiation, including charged particle radiation, thermal radiation, and gamma radiation. A spacecraft as jam-packed with electronics and sensors as Juno needs to be capable of staying functional in such conditions. With this in mind, many measures were taken to fortify the spacecraft. Juno was built with a titanium vault that shields all of its important electronics. It is also equipped with excess solar panel coverage to compensate for weaker sunlight, as well as to stay online in the wake of Jupiter's extreme radiation. Its flyby course was also plotted to avoid encountering Jupiter's massive radiation belts. This is how Scott Bolton and his team were moving when designing Juno. This image, dubbed Jupiter as an exotic marble or a mind of limits, a camera of thoughts, was captured by Juno the day before my 11th birthday. I edited this image for vibrance and clarity. This is an image of Io, one of Jupiter's moons. Io is the most volcanically active body in the solar system. Juno has been able to photograph and provide valuable information about many of Jupiter's moons alongside Jupiter itself. Instruments. Juno is equipped with a suite of 9 scientific instruments. These include the MWR, GRIM, MAG, GS, JADE, JEDI, WAVES, UVS, and JCM. These are mouthfuls even when abbreviated, so each instrument and its function will be explained in the next few slides. Great. Now I gotta explain all of Juno's instruments. Here goes. MWR. Juno's microwave radiometer allows the spacecraft to see under Jupiter's visible cloud cover. It measures 6 separate frequencies ranging from 600 megahertz to 22 gigahertz to peer hundreds of miles below Jupiter's surface. According to the mission's website, quote, "To see what's under the cloud tops, the MWR will measure the radiation emitted from inside the planet. The clouds radiate in all frequencies of the radio, microwave, and infrared ranges. But only microwave frequencies can make it through to the thick clouds. The depth from which the radiation can escape depends on frequency, so measuring different frequencies of microwave radiation, the MWR can study different layers of Jupiter's interior. The MWR consists of 6 radiometers designed to measure the microwaves coming from 6 cloud levels. The MWR's purpose is to detect what chemicals are present at different depths and search for materials like water, ammonia, and nitrogen. It can observe weather features and phenomena like lightning, offering us a glimpse into its origins and its inner workings. GRIM. Further discussing weather detection, the Jovian Infrared Auroral Mapper contains a near to mid-infrared spectrometer, 2 to 5 micron sensor, and an imager, and surveys around 30 to 45 miles into Jupiter's atmosphere for auroras and thermal signatures. Quote, GRIM provides images of the auroras in the wavelength of 3.4 microns in regions with abundant trihydrogen cations. By measuring the heat radiated by the atmosphere of Jupiter, GRIM can determine how clouds with water are flowing beneath the surface. It can also detect methane, water vapor, ammonia, and phosphine. Compared to the aforementioned MWR, GRIM looks only slightly below Jupiter's surface clouds. It observes different wavelengths than the MWR and is used specifically to study weather patterns below Jupiter's surface at higher altitudes. GRIM observes thermal radiation to detect atmospheric temperatures and composition.
MAG.
The magnetometer instrument aboard Juno surveys and maps Jupiter's entire magnetic field. It sports 2 flux gate magnetometers and the Advanced Stellar Compass, or ASC, which reinforces locational and directional accuracy. Since Juno is an orbiter, MAG gives us a first-of-its-kind global high-res mapping of Jupiter's magnetic field. MAG is also crucial in studying Jupiter's dynamo, see the next slide, which is caused by a swirling ocean of metallic, conductive liquid hydrogen that is formed by the immense pressure deep within the planet. The MAG also revealed that Jupiter's core is more likely to be fuzzy than was previously believed. What is a dynamo? A dynamo, according to dynamo theory, is the source of a celestial body's magnetic field. Deep within Jupiter, convection causes the hot metallic hydrogen to rise and the cool hydrogen to sink. Jupiter's rapid spinning 10-hour days, despite being around 1,300 Earths in volume, turns the hydrogen into spiraling streams. Since the hydrogen's electrons are being squeezed smooth off, the springy flowing streams generate electricity and create a magnetic field. Quote, the theory describes the process through which a rotating, convecting, and electrically conducting fluid can maintain a magnetic field over astronomical timescales. End quote. Harvard University. GS. Juno's gravity science experiment/instrument maps Jupiter's gravitational field. The planet's gravitational field changes often, and monitoring it can provide info about its interior. The GS and MWR operate mutually exclusively. If one is on, the other is off. GS monitors Juno's movement when in Jupiter's gravitational field, rather than using sensors or scanners pointed at the planet. Quote, when probing Jupiter's gravitational field, Juno switches off its microwave radiometer instrument and turns on its gravity science instrument. Variations in Jupiter's inner structure will have tiny effects on its gravitational field, which will ever so slightly alter Juno's orbit. End quote. From missionjuno.swri.edu. Jade. The Jovian auroral distributions experiment is probably the most complex instrument aboard Juno. So, naturally, this slide will be the most brief in explaining any of Juno's instruments thus far. To grossly oversimplify, Jade is a set of 3 sensors that detect the charged particles that cause Jupiter's auroras as opposed to the light or radiation they emit. That's all you really need to know. Jedi. The Jupiter Energetic Particle Detector instrument does exactly what Jade does, just with higher energy particles. See this screenshot. Waves is technically a collection of instruments for studying Jupiter's magnetosphere. Unlike MAG, it detects radio and plasma waves or electric fields instead of magnetic fields. It's made to capture the more dynamic interactions that take place in Jupiter's atmosphere that form its auroras. UVS. Juno is equipped with an ultraviolet spectrograph that captures UV light, which is particularly useful for providing images of Jupiter's auroras as opposed to just measurements and data. Quote, specifically, UVS is focused on making remote observations of the aurora, detecting the emissions of gases such as hydrogen in the far ultraviolet range of light. End quote. Wikipedia. JCM. Lastly, JunoCam is the spacecraft's aptly named telescopic camera unit. It takes pictures of Jupiter within the visible light spectrum. It has a field of view of 58 degrees and takes pictures as Juno rotates. JunoCam was mainly planned to photograph Jupiter's poles, but it ended up taking many more pictures during its extended mission, and it was also used to take pictures of Earth while Juno was still en route to Jupiter. Challenges. The Safe Mode Incident. On the 4th day of April of 2016, during its second approach, or Perijove 2, Juno entered Safe Mode 2 times. Safe Mode shuts down all of Juno's non-essential instruments and points its antenna directly toward Earth in order to preserve the probe and thus its mission. Though initially thought to be due to Jupiter's aforementioned intense radiation, the incident was most likely caused by a software error. Information on the event's cause is relatively sparse, but in brief terms, from what I've gathered, it's likely that JIRM reported unexpected conditions and triggered a preemptive shutdown. The scientists and engineers in charge made changes and updates to the system and got it back online safely. Challenges. JunoCam. JunoCam's image quality degraded over time due to prolonged exposure to radiation and led NASA to discover a simple yet unexpected remedy in December of 2023. The team decided to repair the camera using a process called annealing, which basically means heating the camera up to fix its components. It was a gamble and initially didn't show any change. However, around a week after the method was used, the image quality improved for a while. What have we learned? Mission Juno has yielded many discoveries, such as the source and shape of Jupiter's lumpy magnetic field, and revealed how it interacts with its atmosphere. Juno also showed us the likely true shape of Jupiter's core, fuzzy and dilute, a discovery that has changed our understanding of Jupiter's origins. Furthermore, an alternative to the theory that its core's said fuzziness was caused by an impact from another celestial object has recently been presented. These and other discoveries are illustrated below and in upcoming slides. What have we seen? From left to right, all are images captured by Juno: an infrared photo of Jupiter's North Pole, a visible light photo of Jupiter, an infrared photo of Jupiter's southern aurora. What else have we learned? Quote, results from Juno on storms suggests that they are far taller than expected, with some extending 60 miles or 100 kilometers below the cloud tops, and others, including the Great Red Spot, extending over 200 miles or 350 kilometers. With Juno traveling low over Jupiter's cloud deck at around 130,000 miles per hour or 209,000 kilometers per hour, Juno scientists were able to measure velocity changes as small as 0.01 1 millimeter per second using NASA's Deep Space Network tracking antenna from a distance of more than 400 million miles, or 650 million kilometers.
A close-up of Jupiter's Great Red Spot from around 8,000 kilometers away. Jupiter's Great Red Spot has been observed for centuries and has shown signs of shrinking as of the past few decades. It previously could be occupied by 3 times Earth's mass, but it is now smaller than Earth and reportedly growing taller.
Summary. Juno is a spacecraft made to orbit Jupiter for research and has brought humanity many valuable discoveries and jaw-dropping images, both of and about Jupiter and its moons. Mission Juno is a coordinated effort between NASA, the Southwest Research Institute, and many other associations around the world. It rewrote a substantial amount of Jovian history as we know it. Mission Juno is a demonstration of strong leadership, cooperation, and planning, which is made evident by its extended mission lasting till at least nearly a decade after it was initially supposed to conclude. It is a monumental success, even in the wake of the challenges it faces today.